is equal to 4 minus u1, 6 minus u2, right? Take minus u is equal to 4 minus u1 and 6 minus u2 belongs to V, such that u plus minus u is equal to u1 u2 plus 4 minus u1, 6 minus u2. So use this addition, definition of addition of first coordinate, then minus 2. So u1 plus 4 minus u1 minus 2, u2 plus 6 minus u2 minus 3, using the definition of addition, right? And that is equal to 2 3, because u1 minus u1 will be cancel out, 4 minus 2 is 2, u2 minus u2 will be cancel out, 6 minus 3, that will become 3. Okay, so for any u is equal to u1 u2, you will get minus u, which is 4 minus u1, 6 minus u2 belongs to V, such that u plus minus u is equal to theta, where theta is identity, which is 2 3, right? So identity or exist, inverse is also exist. So each 5 conditions are satisfied for addition. Now next 5 conditions, try to check. The first condition is for closedness. For any alpha belongs to R, u belongs to V, alpha into u, that will become belongs to V, that is belongs to V. Alpha, try to check that is belongs to V or not. So alpha into u1 u2, that is equal to alpha u1 plus 2 alpha minus 2, alpha u2 minus 3 alpha plus 3. So this vector is also belongs to V, because V is R2 and these 2 coordinates are already belongs to R2, right? So next condition, 7th condition, alpha into distributive law, alpha into u plus V, that is equal to alpha into u1 plus v1 minus 2, u2 plus v2 minus 3, right? Because u plus v, we have u1 plus v1 minus 2, u2 plus v2 minus 3, alpha into, now use scalar multiplication. So alpha into first coordinate plus 2 alpha minus 2, right? So alpha into u1 plus v1 minus 2 plus 2 alpha minus 2, then alpha into second coordinate minus 3 alpha plus 3, because we have definition, this definition, we use this definition, alpha u1 u2, that is equal to alpha into first coordinate plus 2 alpha minus 2, then alpha into the second coordinate minus 3 alpha plus 3. So using this definition we can write down this step. Okay, so alpha into u1 plus v1 minus 2, u2 plus v2 minus 3, that is equal to alpha into the first coordinate u1 plus v1 minus 2 plus 2 alpha minus 2, that is then alpha into second coordinate u2 plus v2 minus 3 minus 3 alpha plus 3. Okay, so alpha u1, you will get alpha u1 plus alpha v1 minus 2, because minus 2 alpha plus 2 alpha will be cancel out here. Just see, this is minus 2 alpha and this is plus 2 alpha. So minus 2 alpha plus 2 alpha will be cancel out. So you will get alpha u1 plus alpha v1 minus 2, and then alpha u2 plus alpha v2 minus 3 alpha minus 3 alpha, that will become minus 6 alpha plus 3. Okay, so this is LHS, this is left hand side, alpha into u plus v, you will get this part alpha u1 plus alpha v1 minus 2, alpha u2 plus alpha v2 minus 6 alpha plus 3. Let's try to check what is our right hand side. Okay, that is alpha into u plus alpha into v. So here is alpha into u plus alpha into v. So that is alpha into u1 u2 plus alpha into v1 v2. Now alpha into u1 u2, by definition alpha into u1 plus 2 alpha minus 2 alpha u2 minus 3 alpha plus 3 plus alpha in v1 plus 2 alpha minus 2 alpha v2 minus 3 alpha plus 3. Now we have to use, this is here in, from this step to this step we use scalar multiplication, which is already given in the statement. Now from this step to this step we have to use definition of addition, which is already given in the statement, right? So that is first coordinate plus first coordinate minus 2. So that is alpha u1 plus alpha v1 plus 4 alpha, right? 2 alpha plus 2 alpha, that is 4 alpha minus 2 minus 2, that is minus 4, and again minus 2. So that's why here minus 6. Okay, and then by definition, what is definition of addition? Second coordinate plus second coordinate minus 3. So you will get alpha u2 plus alpha v2 minus 3 alpha minus 3 alpha, that will become minus 6 alpha plus 3 minus 3. So that's why 3 minus 3 cancel out and only 3 remaining. So alpha u2 plus alpha v2 minus 6 alpha plus 3. So just see, this left hand side part and right hand side part are not same. What is left hand side part? Left hand side, alpha u1 plus alpha v1 minus 2, the first coordinate, and here first coordinate is alpha u1 plus alpha v1 plus 4 alpha minus 6. So clearly LHS is not equal to RHS, left hand side is not equal to right hand side. So definitely this distributive law, this condition is not satisfied to become a vector space. So that's why the given set is not a vector space. You can write down, the given set is not a vector space. Okay. If this question asked in exam, and if you know already that this condition is not satisfied, directly write down this condition. Okay. Here just for your understanding, I written all the conditions up to in which the condition is not satisfied, right? We are starting from first condition, second condition, and the seventh condition is not satisfied. But if this question asks again in the question paper, you can write down directly this condition and give you your answer that the given set is not a vector space. Okay, you don't need to check the first to 6 conditions, that is already satisfied, but the main important part is this seventh condition, that which is distributive law, is not satisfied. Okay, just so try to understand. Next question, question 2b, first part. State only one exams or one that fails to hold for each of the following sets W to be subspaces of the respected real vector space V with the standard operations, right? With the standard operations. So definitely you have already the answer. That means what? This all the sets are not a subspace. This all the sets are not a subspace. Now just try to understand very carefully. We have 5 sets, right? The first, you can see on the screen, the first 2 examples are subset of R2. The second, third example is subset of R3. Fourth example is a subset of set of matrices n cross n, and the fifth one is a subset of set of functions, right? Set of negative functions. Now to prove subspace, what is the definition of subspace? W is a subspace of a vector space V if W itself a vector space. If W itself a vector space. But to prove subspace, you don't need to check all these 10 conditions, right? Just try to check only 2 conditions. The first condition is closeness for addition, that means UV belongs to W, then U plus V belongs to W, and for any alpha scalar and U belongs to W, alpha into U belongs to W, right? If these 2 conditions are satisfied, then you can say that the given set is a subspace of a vector space V. So what I am trying to say, that if you want to prove that the given set is a subspace, you have to take general elements, right? You have to take any U and V belongs to W, and this U plus V belongs to W, right? So starting with any U V belongs to W and U plus V belongs to W, that you have to prove. But you know already answer, that you know that answer that the given sets are not a subspace. So just try to find out the counter example. That means what? Check, take particular 2 elements, that U and V, particular 2 elements, right? And try to prove that given 2 sets or addition of addition of that 2 element is not in the subspace, is not in the sets, right? Or try to prove that alpha into U is not belongs to the set, okay? And try to prove that alpha into U is not belongs to the set. Same situation happen here. You know already answer, that state only one exams that fails to hold for each of the following sets. That means what? Indirectly you have answers that these 5 examples are not a subspace for the respected vector space, right? So just try to check, just try to find out the example, right? That U belongs to W, V belongs to this, U belongs to W, this V belongs to W, and U plus V is not belongs to W. So just we prove that the given set is not a subspace. Okay, so let's take one by one each example. The first one is W is xy. Definitely this is a subset of R2, okay, not a subspace. That we have to check that the given set is a subspace or not, but definitely this is a subset of R2. The first example is a subset of R2. So xy, what type of elements in this set xy where x square is equal to y square? That means what? The square of both the coordinates are same. Okay, so here is the example. Let U is equal to 1 1 belongs to W, clearly, because both have same coordinate, 1 1, so 1 square is equal to 1 square, so definitely U belongs to W. V is equal to minus 2 2, minus 2 square, that is equal to 2 square, that is also belongs to W. So that's why U and V both belongs to W. Now what is U plus V? What is our U plus V? 1 1 plus minus 2 2, right? Use standard addition, that is equal to 1 minus 2, that is minus 1, and 1 plus 2, that is 3. So U plus V is equal to minus 1 3, that is not belongs to W. So minus 1 square is not equal to 3 square. So that's why U plus V not belongs to W. So we prove that W is not a subspace of V, right? Because of to become a subspace, we have for any U V belongs to W, U plus V definitely belongs to in W, right? But here we given example that this U and V, for this U V belongs to W, U plus V is not belongs to W. Okay, so that's why the first one is not a subspace of R2. Let's take second one. What is our second set? XY. W is equal to XY, where XY greater or equal to 0, right? That means those type of element in this set such that multiplication of this two coordinate is always greater or equal to 0. So let's try to check that the given set is a subspace or not. Here is the example. This 1 2 belongs to W because 1 into 2 is 2 greater or equal to 0. Minus 2 into minus 1, that is also belongs to W, correct? Because minus 2 into minus 1, that is also 2, right? So multiplication of this two coordinate is greater or equal to 0. Multiplication of this two coordinate is also greater or equal to 0. So that's why U V belongs to W. Let's check U plus V. What is our U plus V? 1 minus 2, that is minus 1, and 2 minus 1, that is 1. So minus 1 into 1, minus 1 into 1, that is minus 1. So that's why U plus V is not belongs to W. Okay, because only those type of elements are in the set, in this set W, such that multiplication of the two coordinates are greater or equal to 0, but U plus V is not belongs to W because minus 1 into 1, that is equal to minus 1, that is less or equal to 0, right? So here is the reason. So W is not a subspace of V, that is R2. Let's take third example. XYZ, where x square plus y square plus z square is equal to 1. So only those type of elements are in the set such that addition of the square of the coordinates, that is equal to 1. Okay, and this is a subset of R3. So let's take one example. U is equal to 1 0 0 belongs to W because of 1 square plus 0 square plus 0 square, which is 1. V is equal to 0 1 0, that is belongs to W because 0 square plus 1 square plus 0 square, that is equal to 1. Okay, now let's take U plus V, that is equal to 1 0 0 plus 0 1 0, that is equal to 1 1 0. Okay, use standard addition, but see U plus V is 1 1 0 and that is not belongs to W because the addition of the square of the coordinates, that is 1 square plus 1 square plus 0 square, that is equal to 2, you will get 2, so not equal to 1. So W is not a subspace of V is equal to R3. Okay, so third example is also not a subspace. Let's take fourth example. Now this is very important example, this is quite interesting. W where set of n cross n matrices, so those matrices are in this set such that if Ax is equal to 0, then x is equal to 0, right. So if our V is equal to set of 2 cross, just takes set of 2 cross 2 matrices, right. Consider n is equal to 2. So here is the example, take 1 0 0 1 belongs to W. Why this matrix belongs to W? Here is the reason. Ax is equal to 0. Let's take Ax is equal to 0. So that means 1 into 0, 1 0 0 1 into x1 x2. Let x is equal to x1 x2, that is equal to 0 0, right. So you will get x1 is equal to 0 and x2 is equal to 0. So that's why x is equal to 0. So that's why A belongs to W. Now similarly take B. B is equal to minus 1 0 0 minus 1 belongs to W, since Bx is equal to 0, since starting with Bx is equal to 0, so minus 1 0 0 minus 1 into x1 x2, that is equal to 0 0. So again you will get minus x1 0 and minus x2 0. So that's why x1 is 0 and x2 is 0. Okay. Now A plus B. What is A? 1 0 0 1. What is B? Minus 1 0 0 minus 1. 1 0 0 1 plus minus 1 0 0 minus 1. Addition of this 2 cross 2 matrices, that is equal to 0 matrix. Now this is not belongs to W, since A plus B into x. If we starting with A plus B, now A plus B, for A plus B belongs to W, what we have to check, that if A plus B into x is equal to 0, you will get x is equal to 0, right. Starting with A plus B into x is equal to 0, so that is equal to 0 0 0 0 into x1 x2, that is equal to 0 0. So x1 is equal to R and x2 is equal to S. Okay. Why? Because you will not get x1 and x2 both are 0. So definitely in this 0 matrix you have to suppose x1 is equal to R and x2 is equal to S. Definitely R and S not equal to 0. So clearly A belongs to W, B belongs to W, but A plus B is not belongs to